I welcome our keynote speaker of the webinar, Mr. Amit Bhargav sir, a co-founder of Enviro Apps Incorporation, Calgary, Canada. He is a subject matter expert in the field of environmental and regulatory compliances. He has more than 20 years of widely varied experiences in a consulting and industry environment. He has a successful track record of designing and facilitating implementation of an incident management system and other software solution to manage regulatory compliances for the energy industry utilizing an environmental management system approach. Mr. Bhargav is an experienced strategic big picture innovative thinking leader with a strong commitment, business acumen, and diversified experiences across sectors as well as jurisdictions focused on delivering environmental regulatory solutions. He is a professional engineer with 2 master's degrees in chemical and environmental engineering. His area of technical expertise include environmental approvals, regulatory compliances, environmental management system, environmental auditing, environmental reporting, emission estimation, air quality assessments, and environmental engineering and management. Now I invite Mr. Amit Bhargav for his keynote address in Innovative Chemistry Solution to Combat Climate Change. Welcome, sir.
Thank you very much. Can everybody hear me okay?
Yes, sir.
Yes, sir, audible.
Thank you very much for inviting me to present today. I'm really happy and proud to be part of this webinar. And I have been working in the industry for a really long time, almost 20 years. This is what I said I came to Canada to do, to work and learn more about the environmental solutions and maybe help the Indian side someday. And so that's today is an industry perspective. I see a lot of really strong academicians in this group today. And I would like to bring a slightly different perspective. But keep in mind, every technology almost starts in a lab environment, in a beaker or in a test tube. But then it is the engineers who work on it to make it and apply it in the real world solutions. And that's what I'm going to talk today is such chemistry solutions that have been now taken up on the engineering side for applications. So with that, let me share my slide here. So everybody able to see the screen here?
Yes, sir.
Yes, sir, it is visible.
Yes. Okay. Thank you so much.
Sir, you are not audible, sir. Speak aloud.
Okay, sorry. Yeah. So first thing is climate change really happening? I don't think we can settle this controversy here. It is always a big hot topic, and there are always 2 sides to this. So we're not going to go there. Definitely there is data that is suggesting that there is global warming or the temperatures rising, and there are patterns in the climate in climate that we are observing today that have been changing. And it's also there is a lot of different schools of thought regarding whether this is driven by anthropogenic, that is by humans, or is it natural? And that also let's keep aside. Let's focus on what is happening in terms of greenhouse gas emissions. And as you can see in this chart, a lot of the greenhouse gas emissions which contribute to climate change or global warming are electricity and heat. So because of electricity and heat, which is our way of life. So really, all the air conditioners we use, or in Canada, all the heating we use generates a lot of greenhouse gases. And that then also we should look at other items such as transportation. They're also quite significant industry. Then there are land use changes because we need more food for human population. So there's a lot of things that contribute to greenhouse gas emissions. And what we are going to talk about today is how our Canadian technologies, and these are all very new technologies that are trying to combat climate change. And remember, they always start from chemistry side. So these are all very new and quite upcoming technologies that are trying to tackle combat, or rather tackle climate change. So just a disclaimer here, EnviroApps does not represent any of these technology providers. This is purely a research-based presentation that I'm providing, and there are certain limitations because of proprietary technology involved here. So keep that in mind. So there are these three companies. One is called Carbon Engineering, another one is called Carbon Upcycling Technologies, and Clean O2. So what do these three companies do? Let's look at one by one. So let's start with Carbon Upcycling Technologies first. So this company is a very new and upcoming company, and they are trying to create solid materials. Basically, they're absorbing CO2 into solid materials and making them better. So this is entirely based on nanotechnology. So you must have heard nanotechnology being quite a interesting field. This is what is happening today. So this company has three different lines of business. They have three products basically. So one is concrete additives, and they also make anti-corrosion coating as well as plastics. So when you talk about concrete additives, so basically they take conventional fly ash from say power plants, and they and other similar materials, and then they enhance it with CO2 to create concrete additives which actually increase concrete strength and reduce cement use. So when you add CO2 as to this SCM, this material, you're reducing the amount of cement that will be used to make that same amount of concrete. So that's where some of the greenhouse gas emission savings come from, besides making it more durable. And then the second thing they do is they basically have a coating which is comprised of a water-based solvent powder formulation, and it forms an impermeable layer against acidic elements when you apply it to concrete surfaces. And then the third thing they do with this technology is they have a CO2 derived polyethylene nucleating agent, which improves barrier performance and reduces cycling time. So basically plastics, when you're molding plastics, if you can save time for it to set up, it is a huge
Am-
in
Amit
terms
sir,
of
can you
cost.
be little louder?
Sorry. Sorry, I did not catch that part. Maybe I'll close my video here because it can slow down things. Yeah, can you say that again, please?
Sir, can you be little louder?
Okay, you're not getting the voice.
Okay, thank you, sir.
Okay, so sorry, I didn't realize that. So plastics is the third thing. So when you're molding plastics, then if you can improve the cycle time, which is basically reducing the time it takes to set that mold, it can be a huge improvement in terms of cost savings. So that's what this third product is about, that carbon upcycling is doing. And so how do they do this? So basically, they select materials. They select materials such as feedstocks such as fly ash. Now, fly ash is also dependent on the quality of coal. That is, so they're classified as class C and class F. Also slag, graphite, talc, pumice, and other. So they take that material, and then what they do is basically they put it in a reactor and pressurize it with the CO2. And that CO2 is coming from a point source emission, which is like, say, power plant is burning coal to produce electricity. So they take that carbon dioxide, and then they use that carbon dioxide into this reactor. And then this material is treated through a patented process. It's called MACE, mechanically assisted chemical exfoliation. So using this process, they then create an end product, which is a suite of CO2 enhanced nanoparticle additives. And that's what they use in their products like concrete mixes, corrosion coating, and then plastics. So this is kind of the technology that's carbon upcycling is using. And then let's talk about the second company. They basically do direct air capture. So it is like your millions of trees that take up carbon dioxide and then release oxygen. But they do this in a very large scale and very fast. So this is the technology. So basically, they pull in air, and then through a series of chemical reactions, they extract that carbon dioxide from it and then return the rest of the air back. And like I said, plants and trees do this every day. And they can do it with a smaller land footprint, and they can make it in a pure compressed form that can be stored underground or reused. And we'll go into more detail as to how they can store it underground or how they can reuse it. So how does this technology work in detail? So the process starts with an air contactor, which is a large structured modeled of industrial cooling tower. So it is like a cooling tower. Sorry, somebody raised hand there. Yeah, any question there? Okay, so basically, a giant fan pulls air into this structure where it passes over thin plastic surfaces that have potassium hydroxide solution flowing over them. So then this solution chemically binds with the CO2 molecules, removing them from the air and trapping them in the liquid solution as a carbonate salt. So then basically this CO2, which then gets absorbed in the carbonate solution, is put through a series of chemical processes to increase its concentration and then purify and compress it. And it can be delivered in gas form, ready for use or storage. And so this whole process involves separating the salt out from solution into small pellets in a structure called a pellet reactor. These pellets are then heated in a calciner in order to release the CO2 in pure gas form. The step also leaves behind processed pellets that are hydrated in a slaker and recycled back within the system to reproduce the original capture chemical. So how is this used? So this is the process we just talked about. It is air being absorbed into the solution, capture solution, which is carbon dioxide rich. Then it goes into a pellet reactor, which then after adding energy to calciner, and it can release the heat and the pure CO2. So how does this apply? So basically, you can get that air from the atmosphere, capture all that atmospheric CO2, and sequester that CO2 into geological storage. So these are basically like your oil and gas wells that have been depleted, that have been produced. You have taken out oil and gas out of it. You can inject CO2 in that geological formation. So on the other hand, you can also do air to fuel plants where you can capture that air. You can also you can do use hydrogen and carbon dioxide to then produce fossil fuels. These will be synthetic fossil fuels, and then basically for synthetic fuels, and they will not have much of a carbon impact because you've already absorbed that CO2 from from air. And like I said, this injection of CO2 can actually you can produce more oil through it through enhanced oil recovery, and that's another way of using the technology to produce fuels that are much or really low carbon. So the third one and the last technology we're going to talk about today is the carbon capture soap. So lot of the not lot, but all homes in Canada utilize furnace. So every house has a furnace in their basement, and that's what is used to heat homes. And because the climate is really cold here, and so this company, Clean O2, has come up with a technology that basically uses that CO2 from those furnaces. And now, earlier they started with homes. Now they're working on bigger scale. They have now come up with um, with units that can basically use it for industrial scale and for building scale. So this device is called Carbon X, and it's about the size of two refrigerators, and then they can be fitted to a natural gas powered boiler to reduce both energy use and GHG emissions. And then this unit actually takes the flue gas through the reaction chamber that uses heat to recover the CO2, and it is then combined with a carbon reduction chemical to create carbonate. So this is the feedstock for soaps. So this becomes a valuable byproduct. And so it could be sodium hydroxide, potassium hydroxide, you can create carbonate. And the waste heat generated from the chemical reaction is then also used to preheat the water that goes into a building's domestic hot water tank. So this is how the technology looks like. It is basically, you can see here, there's a boiler and every house has one. So this is the company that's doing that. And now every bigger building, industrial plant, they would have heating boilers and water heaters. So it takes the flue gas from the exhaust and then combines it to form carbonate, which is in this case commercial grade pearl ash production. And then the heat generated in the reaction actually can be used to heat water. So in summary, we have talked about three different technologies, and all of them are working to combat climate change. These are the benefits you can get from such technologies. You get cost savings. As you can see, when you replace cement in concrete, you're going to get cost savings from less cement consumption. If you look at number two there, you can generate the carbon engineering solution. You can generate synthetic fuel, which technically could be cheaper, although the technology needs to get to scale to be able to get there. And then the third one, again, you're generating a valuable byproduct. So all these three technologies are related to cost savings as well as emission reduction. So they're all reducing CO2 and emissions. And then all these three are actually reusing carbon as well. So this is in a high level an overview of these three technologies that I'm happy to present today. And with that, I will open it to any questions. So are there any questions?
मिनट इधर
आप announce कर दो. Anyone? If any question from the audience side.
Yeah, I see one question in the chat there. How can such technologies be applied to local setup? So if you think of technology such as, let's say, the clean O2 technology, so that's definitely applicable in this case. You know, even in the Indian market, there's always building, you know, there's always hot water boilers in every building that we can use, and then it's a matter of creating soap out of it. So definitely it can be applied. All these technologies, keep in mind, are very new, so they have to get to a scale. So when they get to a scale, the cost goes down. So they haven't reached at that point. And another question I'm seeing there is, what is the cost of carbon soap which is available in India? Actually, it is not. It is just starting here in Canada, and I'm sure they'll be expanding. Right now, I do not know the exact cost of carbon soap, but really, it is the cost of the unit itself. So when you get the cost, when you install the unit, then there is some there's not much input to it except for the sodium hydroxide or potassium hydroxide, and other than that, it is a byproduct. So I see another question: how can we inject atmospheric CO2 to permanently store? So this technology has been around for, I would say, at least 40, 50 years. And different components of that technology basically is available. And so basically what they do is, it's like drilling a gas well. So you drill a gas well and you have casing, and that casing can be used to reach the geological formations. So not everywhere you can do this. It has to be certain geological formation where there is a cap to it. So once CO2 goes in there, at the lower level, at that level, there's always brine, there's salt solution there. So CO2 goes in that geological formation and it gets absorbed in that brine solution, and then it stays there. But you have to find the right geological formation to be able to do this. You cannot do this everywhere. So composition of carbon soap. So pearl ash is what you get out of this, and that can be used to make carbon soap. So sorry, I don't know more detail around that, but all chemists would be able to help here.
Okay, thank you, sir, for sparing your valuable time
from your busy schedule and sharing about Canadian technologies to combat climate change, carbon utilization technology, and carbon capture soap. The talk was very beneficial, and I hope we, by following this technique, can reduce the emission, reuse the carbon, and can effectively reduce the cost. Thank you, sir, for your nice talk, and we feel sorry for any inconvenience caused due to time concern. Thank you so much. Thank you.
No, not at all. This is a pleasure to be part of the presentation here today, and really happy to attend and talk about Canadian technologies.
So really interesting and informative. Thank you so much, sir.
Thank you.